Hello and welcome to Algebra 2, lesson 2.4. So what we're going to be looking at today is the quadratic function specifically. So these are parabolas. So let's go ahead and get started. So first thing we have is the standard form of a quadratic equation. And that standard form is y equals a x squared plus bx plus c. Okay, where a, b, and c, okay, those are constants or just numbers. All right. So I know a lot of people have graphing calculators. So what we're going to do is either A, you're going to use a graphing calculator, or B, you're going to go to desmos.com/calculator, which I'm going to go ahead and do that now. Okay, we wind up with right here our graphing calculator. Okay, and if we go ahead and we enter this function that it asked us to enter, we have this calculator here. We go x, it's going to keep doing this for me because I'm on this tablet, x squared plus 2x minus 5. All right, we could see that this is how it's graphed for us. All right, so we could see that the bottom of our parabola is at -1, -1, -6. So if we go back here, we can kind of graph this out where we see that this is going to kind of look like this. All right, so notice that right here, the a is a 1, and it's positive. So when it's positive, our parabola faces up. Now let's do the next one. I can get rid of that one. And then I have an x. It's a -x squared. Plus 3x. Plus 7. All right, and now we notice here that our vertex is at 1.5, 9.25. Okay, and we notice that the bigger part is our parabola is upside down. So when that first term is negative, our parabola will actually be upside down. Okay, so if this is negative, it's upside down. If it's positive, it's right side up. Looks like a smiley face. So positive is smiley, negative is frowning, just like real life. So the vertical line that divides the parabola in two equal parts is called the axis of symmetry. So if you think about it, if I were to draw a line right down the middle of our parabola, it kind of breaks it in half, where if it folded on itself, right? If I took this part and I folded it over the line, it would just kind of match up with the other one. Okay, that's called our axis of symmetry. Now the formula to find our axis of symmetry for the x coordinate is -b over 2a, or you can call this, some people call this like the vertex formula. Okay, -b over 2a. So remember, if we're going to color coordinate this, this is our a, all right? And this is our b. All right, so since it's +2, this would be -2. So if we went ahead and we used it for this one, this would be a -2 over 2 times 1. All right, so then you have -2 over 2, which is just -1. So that's the x coordinate. So if you noticed on this one right here was -1. So that tells you where your axis of symmetry is. It's on where x equals -1. So the turning point of the parabola is called the vertex. So that's the bottom of your parabola right there, right? So this is your vertex. So when the vertex is the lowest point, it's called the minimum. And when it's the highest point, it's called the maximum. So this one right here is your minimum. And right here, this would be your maximum. Okay? Now to find the vertex, by the way, when we've gone ahead and we've solved for -1, we just plug it into our formula to find the vertex. So basically, for this one here, this would be a -1 squared plus 2 times a -1 minus 5. So this is 1 minus 2 minus 5. So 1 minus 2 is -1, and -1 minus 5 is -6. So that is the y. So our vertex, if you remember, was -1, -6, which is what was in that graph. All right, so let's determine whether each function has a minimum or maximum, then find the axis of symmetry. So right here, I notice that this 4 is positive. So that's going to have a minimum, because it's going to look like this. Now, to find the axis of symmetry, you have this -b over 2a. So there is no b, because technically this is 0x plus 0. So b is just 0, because this is your b right here. Your a, which is there, is 4. So 2 times 4 is 0 over 8. When we have 0 over 8, that's just 0. So our axis of symmetry is x equals 0. Now our vertex, we take this 0 and we substitute it in for x, such as 4 times 0 is 0. So our vertex is 0, 0. All right, let's try number 2. I see it. This is negative, so we're going to have a maximum because it's going to look like this. Our axis of symmetry, -b over 2a. So our b is 6. So -b would be -6 over 2 times a -1, because that's a negative. So that's -6 over -2 is 3. So our axis of symmetry is x equals 3. Now we plug 3 in, negative times 3 squared plus 6 times 3. Well, that's -9 plus 18 equals 9. So that means my axis of symmetry is my vertex is 3, 9. All right, so I'll let you guys go ahead and try 3 and 4. All right, so graphing by table. So when we use a table of values, we're going to start putting some values in. And first we're going to find the axis of symmetry and the vertex, then place the vertex as the middle row, and then we're going to graph. So for instance, over here I'm going to use my -b over 2a. So for this one, I see that my a, I don't have a b, so that's 0. So we already know we're going to have 0 here. So it equals 0 for my x. So when I plug 0 in, -3 times 0 squared is just 0. So 0, 0 is my axis of symmetry. So now, all I'm going to do now is I'm going to start graphing some points below and above. So I go -1, -2, -3, and 1, 2, and 3. So I plug it in to my value here. -3 times -1 squared is just -3. All right, so -3 times -2 squared, okay, that's just going to be -12. And you see how this is going to work. That would be -27. And this will be -3. And this will be -12. And this will be -27. So if I go in and graph this, there is my vertex at 0, 0. Then I have -1, -3. Then I have -2 and -12. So it's going to be all the way over here. And same thing here. This will be on this side. This will be over here. This is going to be a parabola that kind of goes like this. And it's rounded. All right, so what's my domain? Well, you notice that these arrows, they keep going this way, and they're going to keep going forever. So the domain of a parabola is always all real numbers. Now the range, if you notice, it's just going to be the vertex, which is 0, and it's going down. So your range is just going to be y is less than or equal to 0. All right, so let's try number 6. Number 6, I'm going to go ahead and find the vertex. So I have a negative b, so my b is negative 6. So positive 6 would be my negative b, right? That's the opposite, over 2 times a, and a is just 1. So 6 over 2 is 3. So that means my vertex is at 3. So I do 3 squared minus 6 times 3 plus 11. 9 minus 18 plus 11. That's negative 9, so it just gives me 2. So that is my vertex, 3, 2. I can go and graph it right away if I want. There it is. That's my vertex. So I'm going to go with a 2, a 1, and a 0, and a 4, a 5, and a 6. So if I go ahead and I graph these other parts, I have a 2 squared minus 6 times 2 plus 11. So 4 minus 12 plus 11. So that gives me negative 8 plus 11 is a positive 9. Is that right? No. What did I do here? I have 2. That's 4 minus negative 12, which is negative 8, plus 11 is 3. I'm sorry. That is 3. So that'll be 3. And then I have, for 1, it would be 1 squared minus 6 times 1 plus 11. Well, 1 minus 6 is negative 5, plus 11 is positive 6. And 0, well, 0 squared minus 6 times 0, well, these go away, so this will just be 11. And then if we did it on the other side, we find the same results. That's how it should look, very symmetrical. So now that I have that, what I'm going to do is graph it. I have this is my vertex, 3, 2. So I have a 2, 3. I have a 1, 6, and a 0, 11, which will be up here somewhere. And then you notice on the other side, I have the same deal. So my parabola is going to look like this, where my domain is still all real numbers, and see how here's the lowest point and it goes up. So it's going to be y is greater than or equal to 2. And look, and there's my 2 right there. There's my 0. All right, so I'm going to let you guys do 7, 8, 9, and 10, and then I will come back to help you during class. If you have any questions, let me know.